Hello, we are here for one more lesson of this AxisVM training course, and the topic for today will be the dynamic toolbar or dynamic analysis. Following all the previous toolbars, and in the last lesson we've seen the parameters for vibration. So following this concept, let us go to the dynamic toolbar. It is similar. We need to create load cases with dynamic loads, and then we can assess the dynamic analysis dialog box clicking in this icon. So dynamic analysis determine time-dependent displacements and forces due to dynamic loads or nodal accelerations. And this type of analysis can be performed either in linear or non-linear models where you have dynamic loads defined. So when we are going to define this, we get this big dialog box where we have a couple of options. And starting with this area here, load cases, we can select in this static load case or combination. We can select the load case or combination to apply during the analysis. If we select none, we apply only dynamic loads. Then dynamic load case, it's the same according to what we have defined. We choose the dynamic load case. Moving on to solution control, we can define a couple of things, being this an analysis that is time dependent, so we can define the time increment to study and the total time to study, and we get this graphic. Then we have option for tracked mode, and this is something to plot the displacement of the selected node in the given direction during the analysis. And another option here, called it Rayleigh damping constants, which is the damping matrix determined from damping constants, and we have a formula for that, which I will not explain in this video, but you can see about this particular formula and all the variables inside, what they mean in our theoretical course. An option here to consider static loads and nodal masses. So if checked, it will influence these constants about one of the parameters, the parameter m. And option for saving results, all steps or only at regular intervals that can be defined if we activate the function. Then moving on to this area, nodal masses, if on, it will be taken in account during the vibration analysis, and we have these options here: concentrated masses or convert them to loads. We have also a couple of options for the masses only, element masses, or convert masses to loads also. And an option for mass matrix type, which if it is checked, uses the diagonal matrix type. Regarding non-linearity, we have two options. The first one, to follow the non-linear behavior of materials. If we have non-linear elements defined, we can activate or deactivate this specific behavior. Or if we activate this second option that we call follow geometric non-linearity of beams, trusses, ribs, and shells, with this option, the loads will be applied to the displaced structure in each step. And finally, we have a couple of convergence criteria. So we can define a maximum number of iterations, and we can define conditions for displacements, forces, and work to try to find a solution with the number of iterations that we have defined. And with this, we see all the options for the dynamic analysis. If you need any other help besides what we mention and describe in this video, let us know, and we will give you all the necessary support.